Lesson 6.2, Substitution. We are going to solve a system of equations by the substitution method. The standards involved from Algebra 1 are 2.1, 5.3, 5.6, and 9.1. So yesterday we solved systems by graphing, and I told you I feel like that is probably the least accurate way, and it is. This is an exact method, and you're using more algebra. The good thing is we did this a little bit last year where they gave you a system such as 2x plus 10, or I'm sorry, 2x plus y equals 10 for one equation, and then the other equation was x equals 3. Well, when they give you x equal and y equal as one of your equations, that's awesome because they've actually found half the answer for you. So saying that x equals 3 just means that 3 is already done for the x point. To find the matching y, then, you would plug the 3 in place of the x. Okay, so we put it in here and solve for y. So 2 times 3 is 6. You subtract 6 from each side, and y was 4. So that system, 2x plus y equals 10 and x equals 3, were two lines that intersected at the point 3, 4. So that's going to be kind of our job here, is to find what point that they intersect at. Now, you have to really have either x equals or y equals to do a substitution, because you need to know what the value is of the one or the other to substitute it into the other equation. If they don't give you an x equals or y equals, and the directions insist you do substitution, well, then darn, you have to make one of them x equal or y equal. Okay? We're going to have more options towards the end of the week, so I think you'll see what I'm talking about then. Let's look at the first example. Y equals negative 4x plus 12. That's one equation. The other one is 2x plus y equals 2. So the one that is the x equal or the y equal, that's the one that you substitute what it's equal to. So that means negative 4x plus 12, and you substitute it into the other equation by doing this. You would write 2x plus, and I'm going to put it in parentheses, and I feel like you always should, okay, because you never know what's out there in front of it. Right now there's a plus sign, which means nothing, but if there was something else, you need to distribute, okay? So just kind of get in the habit of doing those parentheses, and in the parentheses I'm going to put negative 4x plus 12, and that equals 2. So I am using this second equation there, 2x plus y equals 2, and in place of y, I put negative 4x plus 12. Do you see how I substituted that in? Okay, now the good news is that equation now only has the variable x in it. The problem with the 2 up above is it had an x and a y. And you can't really solve an equation that has two different letters. You can only solve when it is kind of just down to one letter. So that's how this is going to work. You want to get it down to one letter. So what I would do with this is this plus in parentheses here, there's nothing to distribute through. So this is really 2x minus 4x plus 12 equals 2. And at this point, you are just solving, combining like terms. So 2x minus 4x, negative 2x plus 12 equals 2. I need to take the 12 over, so subtract 12. And negative 2x would equal negative 10. And then finally divide by negative 2, and you would find that x is 5. So what that tells me is I have half of the answer done. I start my ordered pair, which is my answer, and I put 5 in the x place. Now, once I find one of them, x or y, you take that value, plug it into one of the first two equations. In this case, you'd want to plug it in here. Y equals negative 4 times 5 plus 12. So you will find the matching y to the x at 5. So y equals negative 20 plus 12. Y equals negative 8. So I can tell you, when you would graph those two lines, they would intersect at the point 5, negative 8. So we're finding that point of intersection without ever seeing a graph. It's so much more accurate, and there's no chance of trying to figure out, well, did that really hit on a corner, or was that a fraction in the middle, or whatever? Because you could get fractional answers. Okay? So much better than doing that on a graph. Ethan.
So you could only do it if it was like y equals something. What if they're both like 2 equals y plus 2?
Okay, well, that's going to happen. They're going to give you some that aren't x equal or y equal, and then you'll have to work a little bit harder to make one of the equations y equals or x equals in order to substitute. Okay? So later on, you'll have an option, and your option will be to do substitution when the system already has one like this. Tomorrow, we'll look at another method where it's not already x equal, y equal. It's quicker to do it that other method way, okay? But today, we're only doing substitution, so if one of them doesn't have x equal, y equal, you have to make it that way first, okay? That was a good question. All right, let's go on to our next example. Here's one that is, I guess, starts it off right off the bat. Example B, x minus 2y equals negative 3, and 3x plus 5y equals 24. Neither one of them is x equal or y equal, but hopefully you can tell which one you could easily fix. Which one would it be, Jared?
X minus 2y equals negative 3.
Yeah. So let's take x minus 2y equals negative 3, and let's go ahead and fix that by adding 2y to both sides. And therefore, x equals 2y minus 3. Okay? And what we're going to do with that then is this 2y minus 3, that looks like a weird looking 3 with that minus is attached to it, and we're going to plug that in place of that x in the second equation. Is that what you guys were thinking would happen? Hopefully. Okay, good. Now, do you see why the parentheses are important in this one? It's 3 times the quantity 2y minus 3 plus 5y equals 24. Okay? Any surprises there? We good? And now you proceed to solve by doing distributive first. 6y minus 9 plus 5y equals 24. Combine like terms. The 6y and 5y, 11y minus 9 equals 24. My y is on the left, so I'm going to add 9 to both sides. 11y equals 33. Divide by 11, y equals 3. I'm ready to start half of my solution, or I'm ready to start my solution. So y equals 3, so I would put 3 in the y spot. Questions about that so far? So what do you think I'm going to do next? How am I going to finish this off, Tora?
You're going to put the 3 in place for the y next to 2.
Yep, we're going to go back up here and put 3 in that y spot, so that x would equal 2 times 3 minus 3. So x equals 6 minus 3, or 3. So my solution, my ordered pair, would be 3, 3. Okay, questions about that? What do you think? It's a lot of steps and a lot of work, but it's kind of straightforward, isn't it? Like there's no real tricks. One of them has to be x equal y equal. If it's not, you've got to make it that. A lot of them will be really obvious. Some of them you might have to even divide. Like for example, if this one right here had a 2x in front of it, you might even have to divide by 2. But I don't think that's going to happen too often to you. Okay. Let's go on and look at what's coming up with example C then, if there's no questions on B. Okay, so example C, 2x plus 2y equals 8, and x plus y equals -2. Okay, so again, one of them isn't straightforward x equal y equal, so which one do you think I'm going to fix? Maitri? Yeah, let's do that. And let's just go ahead and subtract y again and get that over there. So it would be x equals -y minus 2. Does that sound good? And then we're going to take this -2y minus 2 and put it in this top equation in place of x. So that would make us have 2 times the quantity -y minus 2 plus 2y equal 8. Are you with me? I took what x was equal and substituted it back in up at the top equation in place of x. Now I must distribute -2y minus 4 plus 2y equals 8. And combine like terms, so -2y plus 2y. Uh-oh, what happens there? Cancels out, there is no y, which leaves me with -4 equaling 8. Is that true? No. So since it is false, what do you think the answer is, Josh?
Empty set.
Empty set. So apparently those two lines are what? Parallel. Yeah, obviously they'd have to be parallel. Okay, so they're never going to intersect, so empty set or no solution. Let's look at what the note below says here. If the variables fall out, and it's going to happen, if the variables fall out and the numbers left are equal, then you say IMS, infinitely many solutions, and they are the same line. If the numbers left are not equal, then empty set, those lines must be parallel. Questions about that?